Here's my last example on graphing. It's always a good idea to start by factoring your rational expression because it helps you to discover intercepts and vertical asymptotes. Now that it's factored, I want you to notice there's something different about this rational function. It has a common linear factor in the numerator and the denominator. Now that's going to be crucial. We're going to come back to that. But I am going to simplify just a little bit more. Here's my simplified function. But this is a simplified version of h. Now h does have a domain restriction. It has two restrictions. X cannot be 1 and x cannot be -1 because of these two denominator factors. However, the domain restriction at 1 is a part of the original function, but it gets canceled out. When you have a linear factor that's the same on the top and the bottom, the denominator on the bottom does cause a domain problem. So the domain doesn't allow us to use 1 in the domain. And the numerator has the same factor, which cancels out the factor. And that changes some of the graph characteristics. And the outcome of this is a hole. This is a special case. Whenever the numerator and the denominator have the same linear factor, we're going to get a hole in our graph at, I'll say it that way, at x equals 1. So when x is 1, it's not allowed in the function, but it is going to create like a break. Now normally it would have been a vertical asymptote break, but because the function is simpler now without that linear factor, the graph will be slightly simpler, but there's going to be this hole. Now how do we find the hole? We're going to have to plug in h of 1, but not in the original function. Plug it into the simplified function. So I'm going to plug it in 2 times 1 plus 2 and 1 plus 1, and that gives me 3. So there is a hole here. That is going to be a hole in the graph. So at 1, 3, this graph is going to have a hole right there. So I've got a clue actually about the graph. Now the rest of the graph, we're just going to follow through with the characteristics. I'm going to go kind of fast here on some of these characteristics, but I need to have the y-intercept point. So I'm going to plug in 0 for x and find out what that is. So if I plug that in, 0 for x, I'm going to have 4. So I've got a y-intercept right here at 0, 4. Second thing I want is the zeros, or the y-intercepts. Well, the y-intercepts come from the top, and I want the top to be 0. And I can solve that real quick. I'm not going to go through all the steps, but I find out that x equals -2. So now I have -2, 0. I have a 0. So I've got another nice clue right here at -2, 0. Next, I'm going to look at the horizontal asymptote. So the horizontal asymptote comes from the dominant division, and the dominant division, we see that there is, you can look at it from here. Got a circle, all these circles making a lot of mess here. But my leader is 2x. and I have a leader on the bottom, which is an x, which goes to 2. If I'd gone from the original function, up here is my leader, 2x², and the denominator's leader was x², it's still balanced. Oops, I wrote this one wrong. It was x on the bottom. This one is balanced and this one is balanced. So either way, it comes out to 2. So if you divide the leaders, you're going to get the horizontal asymptote is y equals 2. Now, vertical asymptotes. Originally, they would have come from these domain restrictions. We would have had 2 of them. X equals -1 and x equals 1. But this one is no longer in the story because at x equals 1, it got canceled out with the numerator. So really, there's only one vertical asymptote. And so this one is better to show us that one vertical asymptote. And we have enough actually to make this graph now. So let's put in the horizontal asymptote. The horizontal asymptote was at 2. Let's put in the vertical asymptote at -1. And I should do one more. Let's talk about crosses. Does it cross the horizontal asymptote? So I'd have to solve for y equals 2. So I'd put 2 into the equation and solve that. And I got to go fast now. I can divide both sides by 2. Let's multiply by x plus 1 also on both sides. Sorry, I'm doing a lot of steps here because I'm running out of time. Those cancel. The 2's cancel. So x plus 1 would have to equal x plus 2. And if we keep solving this, I'm going to run out of time. But it says 1 equals 2 because all the x's cancel if I minus x on both sides. That's impossible. So, made a mess there. But I did a quick check to find out, hey, that it doesn't cross. So that's going to make graphing really easy. No crosses. Okay, now one last thing. The tails on this asymptote, since the vertical asymptote is degree 1, the tails are opposite. All right. If it doesn't cross and the tails are opposite, I'm pretty much done. Because this intercept has to come up against this, and it doesn't cross. So if it's not crossing the horizontal asymptote, it's going to have to go up. So I got a tail going up. I'm going to come down to this hole here, and it doesn't cross, so it's just going to skim across that horizontal asymptote. Likewise, this one. Now this tail is up, so this tail has to be opposite. It's got to go down. And I've got this 0 to hit. Now I know it doesn't cross. I just proved that over here. So when I come on this asymptote, I'm going to have to graph like that. Let's see the actual graph and see how well we did. Okay, there we did. There's the hole. And our branches are reasonably good. So we got a pretty rough sketch. So this idea of a hole doesn't come up a lot, but it does happen when the numerator and denominator have the same linear factor. Hope that helps. Study hard, practice a lot of graphing.